The mysterious interstellar object 3I/Atlas has recently re-emerged from behind the Sun, offering astronomers a rare opportunity to observe this enigmatic visitor once again. Since its initial discovery, the object has captured the fascination of scientists and space enthusiasts alike, sparking debates over its nature, origin, and potential implications for our understanding of the cosmos. Widely believed by experts to be a comet primarily composed of carbon dioxide ice, 3I/Atlas is traveling on a highly eccentric trajectory that takes it through the inner regions of our solar system. Observations suggest that it is expected to make its closest approach to Earth just days before Christmas, before continuing its journey outward, eventually leaving the solar system entirely. This passage is being closely monitored by astronomers using a variety of ground-based and space telescopes, as it presents a rare chance to study an interstellar object up close. One of the most intriguing aspects of 3I/Atlas is its survival of perihelion, the closest point in its orbit to the Sun. Many had speculated that the intense heat and gravitational forces at this proximity would cause the object to break apart, as some particularly cautious models suggested. Harvard astronomer Avi Loeb, who has been at the forefront of speculative analysis regarding 3I/Atlas, had earlier hypothesized in a blog post that the object might disintegrate as it approached the Sun. However, new observational data now indicates that the object has largely remained intact, defying expectations. Images captured by the Nordic Optical Telescope on the Canary Islands clearly show a single cohesive body, with no signs of the fragmentation that some had predicted. Loeb himself acknowledged this observation in a follow-up post, noting that while the object has survived, it continues to present a series of unusual and curious characteristics that warrant further attention. One of the most visually striking features of 3I/Atlas is its prominent anti-tail, a phenomenon in which an accumulation of jets appears to point toward the Sun, rather than away from it, as is typical for cometary tails. This anti-tail is thought to be composed of larger dust particles that are less susceptible to the Sun's radiation pressure, giving the object an unusual and visually compelling appearance. These observations have added to the intrigue surrounding 3I/Atlas, as scientists attempt to reconcile its behavior with established models of cometary physics. For some, the presence of this anti-tail represents nothing more than a natural occurrence, a rare but not unprecedented feature caused by the dynamics of dust particle ejection and solar radiation interaction. In fact, similar phenomena have been documented in historical observations, such as the anomalous tail of comet Kohoutek in the 1970s. However, Loeb has proposed a more provocative interpretation. He suggests that these jets could potentially be evidence of technological thrusters on an artificial spacecraft, rather than purely natural cometary activity. According to his hypothesis, if 3I/Atlas is indeed a visitor from an extraterrestrial technological civilization, it could be using these thrusters to accelerate itself away from the Sun following its perihelion passage. In a recent interview with NBC News, Loeb explained that such a maneuver would make sense for a craft aiming to maximize its exit velocity from the solar system. By directing thrust toward the Sun, the object could take advantage of solar gravity to boost its speed, allowing it to leave the inner solar system more rapidly. This concept, while speculative, has captured the imagination of both the scientific community and the public, raising questions about the possibility of alien spacecraft traveling between star systems. Loeb's hypothesis, however, has been met with skepticism from many of his peers. Most astronomers maintain that 3I/Atlas is likely a natural comet, albeit an unusual one, and caution against drawing premature conclusions about extraterrestrial technology. Pennsylvania State University astronomer Jason Wright, for example, has publicly refuted Loeb's claims regarding the anti-tail. In a September blog post, Wright pointed out that sunward enhancements in cometary tails are not unprecedented and have been observed in numerous prior comets. These features are often caused by large dust grains ejected from the comet that are not significantly influenced by the solar wind. Wright also referenced a 1974 paper discussing comet Kohoutek, highlighting that anomalous tail structures have a precedent in the scientific literature and do not necessarily imply artificial manipulation. Despite the skepticism, Loeb remains undeterred. He continues to analyze the object's properties and movements, cataloging anomalies that he believes could point to an artificial origin. One particularly striking element of his analysis involves the estimated size and mass of 3I/Atlas. Based on the amount of material the object is shedding, Loeb suggests that it could be much larger than initially thought, with a surface area equivalent to a sphere approximately 14.3 miles in diameter. This estimate is roughly 4 times larger than his previous calculations, highlighting the substantial scale of the object. If 3I/Atlas were indeed an alien spacecraft, such dimensions would suggest an enormous craft, possibly even a mothership of sorts, capable of traveling vast distances across interstellar space. Loeb has also speculated on the potential mechanics of alien propulsion. He notes that advanced thrusters could employ exhaust at much higher velocities than conventional chemical rockets, which would drastically reduce the mass of fuel required relative to the overall mass of the spacecraft. In such a scenario, even the loss of mass observed in the object could be consistent with the operation of extraterrestrial propulsion systems. While these ideas remain highly speculative, they form a consistent framework within which Loeb interprets the peculiar features of 3I/Atlas. He emphasizes that maintaining an open mind is essential to scientific inquiry, particularly when dealing with phenomena that challenge our current understanding of the universe. The public fascination with 3I/Atlas is amplified not only by its unusual physical characteristics, but also by the timing of its approach. As the object nears its closest pass to Earth in December, interest in the comet is growing both within and outside the scientific community. Observatories around the world are coordinating observations to capture its trajectory, brightness, and tail structure, while astronomers continue to debate its potential origin and nature. The object has become a symbol of the broader mysteries of interstellar space, providing a tangible example of the types of phenomena that lie beyond our solar system and the limits of our current knowledge. While the possibility of an alien spacecraft is certainly captivating, most experts caution that natural explanations remain the most plausible. Comets are known to display a variety of unusual behaviors, including unexpected tail structures, bursts of material ejection, and rapid changes in brightness. These features often result from interactions between the cometary nucleus, solar radiation, and the solar wind. Nonetheless, the door to speculation remains ajar, as 3I/Atlas continues to surprise observers with its behavior and physical characteristics. Each new observation has the potential to refine our understanding, either confirming it as a natural object or, more extraordinarily, hinting at something far more unusual. Loeb's perspective underscores a broader philosophical point about scientific inquiry. The study of objects like 3I/Atlas forces astronomers to grapple with the unknown, testing the boundaries of conventional thinking and prompting questions about the nature of interstellar travel, advanced technology, and the prevalence of life beyond Earth. While extraordinary claims require extraordinary evidence, the careful monitoring of 3I/Atlas ensures that each new data point contributes to our understanding of such rare interstellar visitors. The scientific method, grounded in curiosity and empirical observation, allows researchers to explore even the most unconventional hypotheses without abandoning rigor. As 3I/Atlas continues on its journey through the solar system, it serves as a reminder of the dynamic and unpredictable nature of the cosmos. Whether it ultimately proves to be a remarkable comet or an unprecedented interstellar spacecraft, the object represents an opportunity to expand humanity's understanding of the universe. Observers are watching closely, anticipating what further insights may emerge in the coming weeks and months. Loeb's cautionary but hopeful words resonate. The universe is vast and full of surprises, and only careful observation and an open mind can reveal the truth about such mysterious travelers. For now, 3I/Atlas remains an enigmatic visitor, its future path and ultimate nature uncertain. yet continuing to inspire both wonder and debate across the scientific community and beyond. In the end, the story of 3I/Atlas illustrates the essence of exploration, an intersection of curiosity, evidence, and imagination. As it approaches its closest point to Earth before departing the solar system, astronomers and enthusiasts alike are left to marvel at the possibilities. Will this interstellar object reveal new secrets of cometary physics, or could it challenge everything we think we know about life, technology, and the cosmos? Only time, careful observation, and rigorous analysis will tell. In the meantime, 3I/Atlas offers a rare gift, a glimpse into the mysteries that lie far beyond our solar system, and a reminder that, in the grand expanse of space, the line between the natural and the extraordinary may sometimes be far thinner than we imagine.